Now we're going to work through right triangle trigonometry. So for some of you, this will be quite a bit of review. For some of you, it's been a while since you've used this. So we're going to go through a detailed work through with right triangle trigonometry. One of the ways that is used right triangle trigonometry and trigonometry in general is GPS trilateration. So when you're trying to detect or trying to determine a certain position on Earth, the GPS device is talking to a minimum of 3 devices to know where the actual location is, and this is called trilateration. So with right triangles, we have 3 sides. The longest side is the hypotenuse, and that is the opposite side of the right triangle. Then we have whatever angle in question that we have. So let's say this is the angle that we're focusing on. Opposite of this angle is the opposite side, and then in between the right angle and the angle that's in question is the adjacent side. So the equivalent of this, let's say this angle up here was the angle that we were actually looking at. This would be the adjacent side, and then this side would be the opposite side, and then this side would be the hypotenuse. The Pythagorean theorem is extremely helpful, and I'm sure you're very familiar with it. Usually the equation that we'll see here is, side A squared plus side B squared equals C squared. And the C represents the hypotenuse. The A and the B represent the 2 sides. So let's go ahead and work through an example here. Let's say we run east for 15 meters and then 9 meters north, and we want to find the displacement. So the best thing to do when we set this up is we want to draw a coordinate axis first. Then we can draw our vectors. And so we're going to go east this direction for 15 meters. And then we're going to go 9 meters north. Now it's important when we add vectors to put tail to tip. So we're going to put this here 9 meters north. And so then the resultant is from where we started here to where we finished. And we can use our equation a squared plus b squared equals c squared. And so we have 15 squared plus 9 squared equals c squared. 15 squared is 225 plus 9 squared, 81 equals c squared. So we add 81 plus 225 is 306 equals c squared. Take the square root of both sides. So c comes out to be 17.5 meters. So this is the direct root. Now really to get displacement we would have to have the angle as well, but we're just getting the magnitude. So we would have to, for the full displacement, we would have to describe the angle. Okay, so make sure your calculator is in degrees. Most of the time you hit the mode button and then make sure degrees are highlighted. If you do not have a TI 83 product or a TI product, you have something else, you may need to look at your manual. You can usually find a copy of the instructions online as well to get your calculator in degrees. There are 3 trig functions that we're going to be using. The sine, cosine, and tangent. And the best way that I've found to remember what they are is this acronym SOHCAHTOA. And there's other ways to remember that, but usually when I write it out, I like to write it like SOHCAHTOA. And this allows you to see the form that you're actually going to use, and this helps us to find lengths of sides. It helps us find the angles as well for right triangles, and so we're going to do a comprehensive review over this here. The first function we're going to look at is the sine function. So sine of the angles equals opposite over the hypotenuse. So let's say this is the angle that we have, and let's say the angle here is 35 degrees, and we have the opposite side, or rather we have the hypotenuse. So let's say the hypotenuse length is 15 meters, and we want to find out what length the opposite side is. How many meters is the opposite side? So the way we set that up is we do the sine of 35 equals the opposite side, which is what we want, over the hypotenuse, which is 15 meters. And then we can cross multiply, so sine of 35 times 15 equals the opposite side. And so we do that in our calculator. You put sine of 35, make sure you close the parentheses, and then multiply that by 15, and the length comes out to be 8.6, which should make sense because this length here should be less than the hypotenuse, and this length, you know, if this was actually 35 degrees, would make sense, you know, being about 8.6. Okay, so now what we're going to do is give you an opportunity to practice this. I'm going to give you this angle down here so you can draw this out. Let's say this angle is 40 degrees. Here's a right triangle side. And let's say I actually give you this, this portion over here. Let's say this is 19 meters, and you want to find out what the hypotenuse is. So the best thing to do is to label your sides. This is the adjacent side, this is the opposite side, this is the hypotenuse. And so doing that will allow you to, you know, set up everything there and get that set. So why don't you go ahead and pause the video here and see if you can work that out, and then when you're ready to check, just hit play. Okay, so sine equals opposite over hypotenuse. So we have the sine of 40 equals the opposite, which is 19 meters, over the hypotenuse. So there's a very common mistake here, and you may have done this where you just multiplied sine of 40 times 19, but you got to be careful here with your algebra because what we're looking for is the denominator. So we can cross multiply. The sine of 40 times the hypotenuse equals 19 meters. And we can divide both sides by the sine of 40. So the hypotenuse will be equal to sine of 19 divided by the sine of 40. And we get 29.55, so 29.6 meters. And that makes sense because the hypotenuse should be the longest, and it is longer than the 19 meters opposite side. Okay, let's go ahead and try the cosine function. So in this case, the right triangle side is here. Let's say this angle here is 23 degrees. And let's say the adjacent side is 5 meters, and we want to find out what the hypotenuse is. So when we set this up, SOHCAHTOA, cosine of 23 equals the adjacent over the hypotenuse. And in this case, the adjacent side is 5 meters. The hypotenuse is what we're looking for. And so here's another case where we have to be careful with our algebra and cross multiply. So the cosine 23 equals, or times hypotenuse, equals 5 meters when we cross multiply. So we're going to have to divide both sides by the cosine of 23. That's gone, so the hypotenuse will come out to be 5 divided by the cosine of 23, 5.4 meters. And so that makes sense. It's the longest side, a little bit longer than the adjacent side, but with this angle being so small, that makes sense. Okay, so now I'm going to give you an opportunity to try this. Let's say this angle here is 14 degrees. And here's our right triangle here. Let's go ahead and label our sides. So this is the adjacent side. This is the hypotenuse. This is the opposite side. And so let's say in this case, you know the hypotenuse is equal to 25 meters, and you want to find out what the adjacent side is. So go ahead and pause the clip and see if you can solve for that side. Okay, so let's see how you did. Cosine of 14 equals the adjacent over the hypotenuse, we know is 25 meters. So we can cross multiply cosine of 14 times 25 is equal to the adjacent side. So the adjacent side, cosine of 14 times 25 is 24.3 meters. And so that is less than the hypotenuse, and with that angle being so small, it can be close to that. So that looks good. Okay, let's look at the final trig function. And in this case, let's say we know the angle is 35 degrees, and the opposite side is, let's say we know the opposite side to be 10 meters, and we want to know how long this side is. So the equation TOA, the tangent of 35 equals the opposite, which is 10 meters over the adjacent. And so in this case, we got to cross multiply first. So the tangent of 35 times the adjacent equals 10. Divide both sides by the tangent of 35. So the adjacent side, 10 divided by the tangent of 35, is 14.3 meters. And the so it's a greater length than the opposite side here. And that's good. Okay, so why don't you go ahead and try this one. Let's say we know the angle down here is 17 degrees. Here's a right triangle, so we know this is the adjacent side, this is the opposite side, this is the hypotenuse. And let's say that we know the opposite side is 10 meters. Go ahead and find out what the adjacent side is. So go ahead and pause the clip and give that a try. Okay, so opposite over adjacent, the tangent of 17 equals the opposite over the adjacent. So in this case, we have another situation where we have to cross multiply first and then solve. So the tangent is 17 times the adjacent equals 10. Divide both sides by the tangent of 17. So the adjacent side comes out to be 32.7 meters. So this is longer than the other side, and that should be because this angle is so small down here. Okay, now you're ready for the inverse functions, and you can still use SOHCAHTOA here because now we're just going to be using the inverse to actually find angles. And so we're going to work through the first one together, and then I'll have you practice the next two. So let's go ahead and say that we know the angle here, theta. Well, actually, that's what we're looking for. Say we're looking for that angle. Let's say the length of this side is 10 meters, and let's say the length of this side is 17 meters. So what we're going to do is the angle theta will be the inverse sine of the opposite over the hypotenuse. So in this case, the opposite is 10 meters, the hypotenuse is 17 meters. So when you do this in your calculator, usually you'll have to like at least if you have a graphing calculator, hit second sign, and then you can put 10 divided by 17 and close the parentheses. And so it has that inverse sign that looks, or that the symbol that you have there. And in this case, the angle comes out to be 36.03 degrees. So that's the actual angle of this portion of the triangle here. Okay, so let's go ahead and try this next one. Let's say we're looking for the angle theta here. Here's the right triangle, so this is the adjacent side, this is the opposite side, this is the hypotenuse. And let's say we know the adjacent side to be 10 meters. Let's say the hypotenuse is 20 meters. So we want to find the angle. So go ahead and pause the clip, and you can resume it once you've tried it and see if you got it. Okay, so adjacent over the hypotenuse. Adjacent side 10 meters, hypotenuse 20. So the inverse cosine 10 over 20 comes out to be 60 degrees. So that's the angle of this side. Okay, so now let's go ahead and try this one. This, let's say we are looking for this angle up here, theta. Here is the adjacent side, here is the opposite side, here's the hypotenuse. Let's say the adjacent side is 20 meters and the opposite side is 17 meters. And you want to find that angle theta. So go ahead and pause the clip and solve for that and see if you got it. Okay. So inverse tangent, opposite 17 meters over the adjacent 20 meters, and we get 40.4 degrees, and so that is the angle over here.